This is proof number 7, and we are given angle 9 is congruent to angle 8. We're trying to prove that the sum of two angles is equal to the sum of two other angles. And we will start off with the given. In other words, saying that angle 9 is congruent to angle 8. And that doesn't lead to any equations right away, so I'll look at the proof statement. It says measure of 5 plus 6 equals measure of 7 plus 9. If I look at 5 and 6, I can see if I added them together, I don't get a different name for that angle because there's no letters in there right now. But even more significant than that, I can say that angle 5 and angle 6 are supplementary. And 7 plus 9, 7 is over here, 9 is over there, but I see that 7 and 8 are also supplementary. And the reason for that is the linear pair postulate. Since they form a linear pair, we can say that they are supplements to each other. Next, supplements means 180 degrees to me, so I can say the measure of 5 plus the measure of 6 equals 180 degrees. Likewise, we can say measure of 7 plus measure of 8 equals 180 degrees. And the reason I know that is because of what supplement means. Supplement means 180 degrees. That is basically its definition. So definition of supplement. Number 4, since this equals 180 and this equals 180, I can use a transitive to say that the measure of 5 plus the measure of 6 equals the measure of 7 plus the measure of 8. And that is the transitive property. So now all of a sudden I almost have what I'm trying to prove. The only thing that needs to be modified here is that I want angle 9, not angle 8. From the given, we're told that 9 and 8 are congruent to each other, so we'll rewrite this with that fact. Measure of 5 plus measure of 6 equals measure of 7 plus not 8, but 9, and that is a substitution. And in that substitution, we took the equation from step 4, we took the fact from step 1, and that's what we're trying to prove. This proof is pretty similar to the last one. We have all these facts in the given. Our proof statement says the sum of two angles equals the sum of two other angles. So as I look at that, angle 6 is over here, angle 1 is over there. They don't have any relation with each other. But since 6 equals 4, and since 1 equals 5, I can look at 4 and 5 and realize that I can say that angle 4 and angle 5 are supplements. On the right side of the equation, it says measure of 2 plus measure of 3. Well, they do form a linear pair, so I can say angle 2 and angle 3 are supplements. And the reason for this is the linear pair postulate. Like the last time, supplement means 180 degrees, so I could say the measure of 4 plus the measure of 5 equals 180 degrees, and the measure of 2 plus the measure of 3 equals 180 degrees. Supplements means 180 degrees, 180 degrees means supplements. This is the definition of supplements. Next, since this equals 180, 180 equals this, then I could say that the measure of 4 plus the measure of 5 equals the measure of 2 plus the measure of 3, and that is the transitive property. Now it's not quite what we're trying to prove. However, we have angle 4, which is equal to angle 6, so we can stick angle 6 in for it. We also have an angle 5 right here. 5 is equal to angle 1, so we can put 1 in where that 5 is at. So we're going to rewrite statement number 4 and say that the measure of 6 plus the measure of 1 is equal to the measure of 2 plus measure of 3, and that is a substitution. And we got that equation from step number 4. We got the facts that 4 equals 6 and that 5 equals 1 from step 1 in the given. So here is that proof. Okay, given that AB is parallel to CD is the first part of our given, and we're going to highlight those lines. Here is AB, here is CD, and the significant thing here is we're going to look at this transversal. So since those two horizontal yellow lines are parallel, and we have this transversal connecting them, we can say that the measure of 2 is equal to the measure of 3, and that's because they're corresponding angles. We call this the corresponding angles theorem. Parallel implies that those corresponding angles must be equal to each other. Next, we'll get rid of these lines. And we're going to look at the other highlighted parallel line. So AD is parallel to BC. We're going to focus on this transversal at the top. And if we look at the parallel lines and the transversal that forms other angles, now we can say that the measure of angle 1 is equal to the measure of angle 2, because parallel implies those alternate interior angles must be equal to each other. We're going to call this the alternate interior angles theorem. So now what we have in our proof is we've said that measure of 2 is equal to measure of 3. We've said measure of 1 equals measure of 2. So if we connect those together, 1 equals 2, 2 equals 3. So using the transitive property, we can conclude this proof by saying that 1 equals 3. Next proof, we have 3 sets of lines and a couple of transversals. Our first part of the given is that L is parallel to M. And then if we look at this transversal that connects them together, we can say that the measure of angle 1 equals measure of angle 2. That's because they are corresponding angles. So corresponding angles theorem. Next, we'll look at the next set of parallel lines that we have. And that is that M is parallel to T. M parallel to T. Here's our transversal, and if we look at how that shapes up, now we can say that the measure of angle 3 is equal to the measure of angle 4. That's the alternate interior angle theorem. Those alternate interior angles must be equal. Whenever the lines are parallel, the alternate interior angles that are formed are going to be equal to each other. Next, K is parallel to R, so this might be the hardest one of these to see. Here is K, here is R, here's the transversal that connects them together, and that creates angles 2 and 3. If we look at where they're located, they're outside of those parallel lines. One's above it, one's below it, so they're on alternating sides. So we can say that measure of 2 equals measure of 3, because parallel implies that those alternate exterior angles must be equal to each other. So this is the alternate exterior angle theorem. Now let's try to string all this stuff together. We want to get measure of 1 equals measure of 4. So in step number 2, measure of angle 1 equals measure of angle 2. In step number 3, measure of angle 3 equals measure of angle 4. But then in step number 4, we said measure of 2 equals measure of 3, so we're able to connect those together. So since 2 equals 3, they have the same number of markings on them. I have to change 1 as well because it was equal to 2. So through a series of transitives, 1 equals 2, 2 equals 3, 3 equals 4, we can conclude by saying measure of 1 equals measure of 4, and that is the transitive property of equality.